Recently I wanted my non-technical stakeholders to truly understand the size of certain features in our codebase. Then I remembered, a picture is worth 1,000 words. Here's what I came up with. First I had to decide how to measure the size of a feature. Even though it's not perfect, I chose lines of code, because it's simple and good enough for my purpose. To ensure a fair comparison, I decided to include any shared code used by these features. So I wrote a simple F# script that's easy to customize for both my current and future needs. The lines of code module contains functions to count lines of code for given files and folders. The project module handles parsing a given project, extracting its dependencies and DLL name. It also uses the lines of code module to count the lines of the project. The analyzer module groups all projects by the top level folder, as these represent the key features in my codebase. It then sums up the lines of code of all projects within the module, including the dependencies of these projects within the codebase. The report module writes the resulting report as a Python dictionary, which will be required in the next step. Finally, everything is tied together by finding all relevant projects in the workspace, loading the projects, grouping the projects by module, computing the total lines of code per module, and generating the data for the next step. When executing the script for a particular codebase using .NET FSI, the result looks like this. With the data ready, it was time to tackle the visualization challenge. The most impressive size comparisons for me are those videos where the sizes of planets and stars are compared. Watching such videos always makes me think, wow. So I did some research and found that Blender was probably the best tool for the job. Only knowing the basics of 3D rendering and nothing about Blender, I spent the next 2 hours watching YouTube tutorials to learn the basics. Along the way, I discovered that Blender supports scripting using Python. I hadn't written a line of Python in years, but with the help of ChatGPT, I quickly set up an initial scene showing spheres that represent the data. Naturally, I added the Python script to version control to keep track of my changes. I then loaded it into Blender using these 2 lines of code. The next few hours I spent experimenting with materials, lights, and the camera, trying to create a stunning 3D scene. Even though it's just a Blender script, it's still code. So of course I included refactoring steps and applied clean code principles. I created small functions for generating spheres, material, and text, and I added functions to set up the light sources, the camera, and the background image. Finally, I used these small functions to build the scene and render the animation. At the end of a long day, after some frustration, but also many small successes, I finally managed to achieve this. And here's the final video from the rendered animation. I know, it's not even close to the videos that initially inspired me, but given my limited knowledge in 3D rendering, I'm quite satisfied with the result. I share the F# script and the Blender script on GitHub, so you can adapt and use them for your own code bases. The link is in the description below the video. If you have any suggestions on how to improve the scene or the animation, I would happily merge your pull requests. Thanks for watching and happy visualizing!